Oh, wow, that car sure looks dirty. Ugh. Oh, I wonder if rocks float. Nope, they sink. Oh, where does it come from? Where does it go? Peterborough's water source starts with the no. Hey, that little turtle looks kind of dirty to me too.
Julius, what's taking you so long? Julius?
Time for our Water Wednesday read-along. Kent sent us this great coloring book called Keep Your Toilets Healthy. Let's read the first page here. The sad toilet doesn't feel good when it's treated like a garbage can. Wipes, diapers, floss, bandages, cigarettes, combs, cotton balls. Oh, that's where it goes. Oh no, I gotta tell Ducky. I made a mistake putting anything but the 3 P's into the toilet. That's gonna make the toilet sad. Only the 3 P's, pee, poo, and paper, can go in the toilet. Oh, Ducky will be so concerned. When we shower, wash the dishes, when we brush, or when we flush, only the 3 P's, pee, poo, and paper. Where does it flow? To the wastewater treatment plant. So, here we go!
Hi, I'm Kent Keeling with the City of Peterborough Environmental Services Division, based at the wastewater treatment plant here in Peterborough.
When we flush the 3 P's, pee, poo, and paper, toilet paper that is, where does it flow? To the wastewater treatment plant. Storm sewers take rainwater and snowmelt through storm sewers to nearby water bodies with little to no treatment. Wastewater from your home, toilets, sinks, showers, travel through the sanitary sewer system to the wastewater treatment plant, where it is treated first and then returned safely to the Autonomy River, where it came from. Here's a bird's eye view of the Peterborough Wastewater Treatment Plant, or WWTP for short. You can see the 115 highway to the south and the mighty Autonomy River to the north. Sewage flows into the WWTP through the sanitary sewer system, mostly by gravity. The sewer pipes slope so sewage can flow without any pumping. But sometimes the geography of a city doesn't allow for sewers to be built this way. Then a pumping station is built. Sewer flows by gravity into pumping stations and is then pumped through a pipe called a force main to an area of the city where it can be discharged, fed into a gravity sewer. At the WWTP, the sewage enters a pumping station that we call the raw sewage pump house. The sewage is pumped up to the start of the treatment process at the headworks. Here, on the right, that's a strong electric, and on the left are pumps. Now look at the doorways in the background. These pumps and motors are huge. The WWTP can treat 68.2 million liters of sewage per day and has a peak capacity of 120 million liters per day for a short period of time. First, it's screening time to remove floating trash and debris like rags, small toys, larger food particles, plastics, and other items that generally shouldn't have ended up in the sewer system in the first place. Each section of screen is connected together in a chain. There are sensors that tell the screens to rotate when material builds. They rotate to where stiff bristle brush and high pressure water clean the debris off. Debris drops down on the back side of the screen and travels to a trailer that goes to the landfill once per day to be emptied. Then to the grit channels. The grit channels allows larger particles with a higher density like sand and dirt to settle out. The grit settles to the bottom of these tanks and are pushed by a screw conveyor to a grit classifier in the screen building. The motion of the water is from adding air at this stage. The air is added to keep things from going septic. See that small tube with the brown liquid coming out? This is ferric sulfate that attracts smaller particles together to form a larger particle so they settle faster in the next stage. Remember that screw conveyor? Here's a picture that shows you what they look like. The screw rotates and pushes grit or screenings along to keep the process moving. The screw conveyor to the bottom of the 3 grit channels pushes the grit to the grit classifier in the screen building, where the grit classifier removes liquid from the grit before it goes into the trailer with the screenings. Next, the primary clarifiers, where the flow spreads out over a larger area to give more time for smaller, lighter particles set to settle out and floatable scum like fats and grease to float to the surface. Flights push the floating scum across the top of the clarifier to a scum trough, which skims the scum layer off the surface and sends it to the digesters. These flights are driven by a system of chains and gears similar to a bike, and when they get to the end of the clarifier, they drop down to the bottom of the clarifier and push the sludge into a hopper at the opposite end, where the solids collected and are pumped to the digesters. The liquid from the primary clarifiers goes to the aeration tanks. Anaerobic digesters use anaerobic bacteria, anaerobic meaning the absence of oxygen, to break down and stabilize the solids removed from the primary clarifiers. For the process to work, the digesters must keep a temperature of 38 degrees Celsius, about the same as your body. This anaerobic digestion produces methane gas. We captured and use it to heat the digesters. Recently, some of the gas is also used to generate electricity. Now to the centrifuge. Biosolids from the digester are a gravy-like consistency. We pump them into the centrifuge with a coagulant, and they go for a spin at a super high speed. The liquid and solids are separated by spinning until the solids are more like soil consistency instead of gravy. Then they're trucked off-site for further processing and eventually fertilizer on agricultural land. The liquid that comes out of the biosolids, it goes back to the grit tanks. Then onward to the aeration tanks, for where microorganisms help to treat it. Final clarifiers. The final clarifiers are similar to the primary clarifiers. The solids and microorganisms from the aeration tanks settle out and flights slowly push the solids into a hopper for removal. Biggest difference? No scum. The microorganisms in the activated sludge settle out in the final clarifier, and we want to keep them in the system. Back they go. Now for the last step, disinfection. This is the last step before the water is returned to the Autonomy River. The water flows through the banks of ultraviolet lights to disinfect the water. The UV light doesn't actually kill bacteria. It disrupts their DNA, so it can't reproduce or infect. Look how all the banks of lights have names. Then, clean, safe, and disinfected water is returned to the Autonomy River. What a wastewater adventure!